Hi there. In reviewing your submission of the weekly assessment quiz number 1, I think the short answer question with definitions are all going well, but then the calculation type question are not very in good shape. So I just make this video to explain the two questions in this quiz 1. These two questions are all about the reverse Laplace transform. We want once we have the S-domain expressions, we want to get the time domain expression, and then also ask for what's the maximum value of that expression in time domain. So first, let's look at the first question. In this example, we have get this results 80 divided by s times s plus 3. So look at this expression, last expression, we try to find the reverse Laplace transform with the exactly same expression. So you probably see goes to the handouts. We have this Laplace transform table. So you look at here, we have this number 9, 1 over s times s plus a. This is similar. So you see our expression 80 over s times s plus 3. So here, I just copy that expression here. So you can see in this expression, we have a corresponding here is a equal to 3. But we have an 80 here. So 80 here, we can treat as a constant value. So constant value multiplied in the s domain is also multiplied by in the time domain. So 80 will keep as a constant value. So the result 1 over a is 1 over 3. So we have 80 over 3. And then expression 1 minus e negative at with the power on the e. So we get this one. So a is 3. So we get 1 minus e negative 3t. So this is the time domain expression. Some of you get like 80 divided by 3 minus 80 divided by 3. So times e to the power negative 3t. That's also correct. It's just a factor into each term in this expression. So this expression, what is the, it asks you, how do you describe this time domain function? So that basically is over here. This is the exponential growth. So this is also, this time domain function is an exponential growing function. And this one growing, so normally it's difficult to say if it's a continuous growth, we cannot have a maximum value, but this one has a maximum value. Let's go to, in the Excel, we calculate this expression. So we know this e to the power minus 3t because it's negative 3t in the power. So t is really large value, then this value will goes to smaller. So this is actually the largest value for this expression. So e to the negative 3t is where it goes to 0. So 1 minus a 0 is goes to a 1. So this 1 times 80 over 3. So that basically 80 over 3 is our maximum value. Let's test this in the Excel. So let's take a look at this expression. So first I give the t's value over here, and then we calculate this e to the power negative 3t. So this is basically the expression in the Excel is using this function exponential with the natural logarithm base e. And then negative 3t. So that's basically that's the expression exponential with negative 3 times this value. So we get this e to the power, that's columns of this value. And then on this side, we just calculate the whole expression, 80 divided by 3 times 1 minus this expression. So basically, we use 80 divided by 3 times 1 minus this value. So if you drag this one over here, you will get the whole calculation. You don't need to calculate every number, but once you insert this equation, you just drag over, it will give you all corresponding to this t's value, the result. And so we draw this one. Once you insert, you can see I select t's value, select that expression's value, and then you can insert recommended charts. And here, so this is the chart we select is this one. So you can see this one will reach its maximum value approximately at this point. That's basically we will get 2. That one were already very close to the maximum, and then it will keep this one. So maximum is 80 over 3, which is 26.666. So that's basically these values are all fit to this maximum value. Okay, so this expression, this time domain, this expression will have a maximum value which is 26.7. And then let's go to next question. We have, so for this expression, this example in page 16 of notes, we have this the transfer function. Get this transfer function is this one. So that's this one. The middle, this one is 2 divided by 11s plus 1. So that gives us. So let's give us 2 divided by 11s plus 1. We try to fit this expression with the value in the table. Here we have 1 over s plus a. We don't have factors in front of s. So we go back here. So we try to cancel this 11 before this s. We divide by 11 for the numerator and the denominator. So we divide by 11, give you s, and this one divided by 11 is 1 over 11, and this 2 over 11, that's 2 divided by 11. This is our expression. We only have 1 on the top, so 2 divided by 11. We see that one as a constant. So here a is 11 over 1 over 11. That's our a's value. So you can see we get a time domain expression. 2 divided by 11. That's a constant value in front. Times this e to the power at, and a is 1 over 11. So e to the power negative at, so negative t divided by 11. So that's our time domain expression, and also describe what's the function in the time domain. This one is basically is this value, but with a factor in front. So this is an exponential decaying function. So this whole function is also exponential decaying with the maximum value. Same thing as we see 2 divided by 11 is our maximum value. That's because e to the power is negative t divided by 11. And this t, once t equal to 0, this is e to the power 0 is 1. And then e to the power a negative value, it will continue to reduce the value, decrease the value. So it will goes to, if this t is larger enough, we will goes to 0 this term. So once this one goes 0, the whole thing will goes to 0. Let's take a look on the time Excel. That's this expression. So we get this one, same thing, we get the t value change a little bit from the top because because divided by 11, we get a smaller value. T divided by 11 get a smaller value. So we look at so this one is when it goes to really small value. So let's give us the really small value. So the largest value is on this point. It's actually the first one. It gives us the maximum value. So same thing, we use exponential with negative t divided by 11. That's this equation, and then we put a total equation, a whole equation here. So that's this one, and then we calculate each one. And then also we use the charts to see this function is also has a this is an exponential decaying function, and it has a maximum value here, which is 0.1818. So we get a maximum value 0.182. And I think that's all. This one is easy to understand. The zeros and the poles. Once we get 0 is the top, the denominator equal to 0. That gives us the total transfer function goes to 0. And the poles is on the bottom, these terms, each term equal to 0. So s equal to -1 and s equal to -2 plus 2j and s equal to -2 minus 2j. This is sometimes we call a pair of the poles. Complex number. I will continue to do this video for the quiz 2. So later on, check this folder to see so hopefully this video will help you to complete your weekly assessment quiz 2. Thank you.